So in this problem, what we want to do is we want to complete the following table for a neutral atom of each element. The key term there is neutral atom. Recall that the protons are going to be positive, the electrons are going to be negative, and if it's a neutral atom, that means that the number of protons and the number of electrons has to be the same. Recall also that the neutrons is going to be neutral. What you see in green here is what was given to us in the problem, and I'm going to be using pink. I keep grabbing the wrong marker. I'm going to be using pink, and we're going to fill in this table together. So N stands for nitrogen, and so we'll put the name here. So that's a nitrogen. If we look on the periodic table, it is the 7th element on the periodic table, and thus its atomic number is 7. The protons is going to be equal to the atomic number, and so that's going to be 7, because the atomic number tells us the number of protons that will be in that atom. Now the neutrons, that has to play with the mass number. So the mass number is going to be the number of protons plus the number of neutrons. So if we take the mass number minus the number of protons, so 15 minus 7 is going to give us 8. So we have 8 neutrons in this isotope, or in this atom of nitrogen. Now, since the instructions told us that it's a neutral species, the number of protons has to equal the number of electrons. And so this is going to be 7. All right. The next row for calcium, calcium is given the symbol Ca. All right, so that's going to be the symbol for calcium. The atomic number is 20. It's the 20th element on the periodic table. Once again, the atomic number is equal to the number of protons. So if we have 20 here, we should have 20 here. All right. The number of protons plus the number of neutrons will give us the mass number. So if we take the mass number minus the number of protons, which is going to be 22, that will give us the number of neutrons. So since it's a neutral species, the number of protons and the number of electrons should be the same. So this is going to be 20 as well. All right. Now it gets a little bit more difficult. So what we see here now is we're missing a lot of stuff, but we have the number of protons, and we know that the number of protons is equal to the atomic number. So this is going to be 38. All right. We can fill in the mass number here as well too, because the mass number is equal to the number of protons plus the number of neutrons, and 38 plus 50 is going to give us 88. Now if you look on the periodic table and you look for the 38th element, it's going to tell us that this is going to be strontium. And its chemical symbol is going to be Sr. All right. We can do the next row, and this happens to be the 14th element, and the 14th element happens to be silicon, so that's Si. And so that's silicon. All right. Now, they give us the atomic number. The atomic number is 14. Remember that the atomic number is going to be equal to the number of protons, and so that's going to be 14 as well there. All right. Now, so the number of protons and the number of neutrons is going to give us the mass number, and so that's going to be 30. The number of protons is going to be equal to the number of electrons, and so that's going to be 14 as well there. Now, I made a mistake here, strontium. I didn't make a mistake, but I forgot to write in the number of electrons. If we're going to have a neutral element, then the number of protons and the number of electrons is going to be the same, so this is going to be 38. I apologize, sorry for that. All right. Now for the very last row, we have the 56th element. So the 56th element is going to be barium. So that's Ba. So that's barium. All right. The atomic number and the number of protons is going to be the same, and so this is going to be 56. Now the number of neutrons will be the mass number minus the number of protons, and that is 82. And the number of electrons, the number of protons, since it's a neutral species, should be the same. So that will be 56. All right. So this question is kind of a unique question. It's a true and false question. So it asks, so is each of the following statements true or false? We're going to start with A. All right, we're going to start with A. So A asks, a proton is attracted to an electron. Now, if you recall, what is the charge of a proton? Well, the charge of a proton is going to be positive, all right? What's the charge of an electron? That's going to be a negative. So if you have a proton, which is going to be positive, and you have an electron, which is going to be negative, absolutely. Those are going to be attracted to one another, and so this is going to be true, 100% true. B asks, the neutron has twice as much mass as the proton. So B simply, is it true that the neutron has twice the mass of a proton? And that's going to be false. False. For the most part, the mass of a neutron and the mass of a proton are going to be very similar, almost exactly the same. For C, the neutrons repel one another. Well, neutrons, their name comes from the fact that they are neutral, so therefore they are not going to repel one another, and so this is going to be a false statement. D, electrons and neutrons have opposite signs. Well, an electron is going to be negative. A neutron, short for neutral, or basically tells us that that particle is going to be neutral. And so they do not have opposite charges, so this would be false. It's the proton that has the opposite charge as the electron, not the neutron. All right. We got a few more true and false. The next problem here is going to be a true and false. It's going to have to deal with periodic trends that we find on the periodic table, which is absolutely, it's a very interesting study. You can learn a lot of chemistry or know a lot of chemistry just by simply following the trends. And the way that periodic table was organized by Mendeleev is absolutely a pure genius. It's just absolutely amazing. It really simplifies. It's really elegant, and it really simplifies how we approach chemistry. It's an amazing tool if you understand it. So it simply asks this: which statement with A through E will be true and which will be false? All right. So the premise of this question asks: an atom of carbon compared to an atom of tin has a larger or greater. All right. So we're looking at the atomic size. So we want to compare carbon with tin. Now tin happens to have an elemental symbol of Sn. And so if we're looking at atomic size, is carbon going to be greater than tin? And the answer to that is false, because tin is going to be below carbon. As you go down the periodic table, that size tends to get much larger, or does get larger. Ionization energy. And this is going to be the energy that is required to give up an electron. And because carbon is higher on the periodic table than tin, this is going to be a true statement. Right. C, the number of protons. Does carbon have a greater number of protons? Well, no, it has a smaller atomic number. Since it has a smaller atomic number, it's going to have fewer electrons, and so this is going to be false. And so this statement asks for number of protons. D asks for metallic character. This is going to be false yet once again, because tin is lower on the periodic table than carbon. And the further down you go on the periodic table, the more metallic the element becomes. And lastly, what we have is the number of valence electrons. All right, so number of valence electrons. Well, the number of valence electrons is indicated by whatever column it's in. Since carbon and tin are in the exact same column, they're going to have the same number of valence electrons. They will not have the same number of electrons, but they will have the same number of valence electrons because they're in the exact same column. And so this happens to be false. All right. If you have any questions, please let me know.